Chapter 11, Vibrations and Waves.
I'm Richard J.
Hello, Dad.
Hello, daughter.
What do you think simple harmonic motion is?
Harmony good. I've never had an ear for music, so I'm not sure. But harmonic motion?
Yeah.
Harmonic motion. Has to do with sound, right? Okay, that's about all I know.
Oh, okay. Next question. What do you think about when you hear the word spring force? What do you think spring force is?
Spring force? Is that like seasonal, or is that?
No, like a spring, like.
Oh, spring force. Oh, I see. Something. Well, it's what do you call that when you compress energy, and then it springs forth? That's about all I know on that one. I wasn't very good at physics either.
Okay, next question. How do you think you would calculate the speed of a wave?
I'd have to have a surfboard.
Thank you, Honorable Fulda.
Glad to have enlightened you, number 3 doctor. I had to think about that one. Thank you.
Section 1, Simple Harmonic Motion.
Hi. One example for simple harmonic is a harp, and Charlene is going to show you.
Simple harmonic motion means the vibration about an equilibrium position in which the restoring force is proportional to the displacement from equilibrium. Charlene is playing a harmonic on the harp. She positions her hand in the middle of the D string while also maintaining her hand position in the shape of a C. As she plucks away from the string, the sound waves hit the walls of Charlene's hand, producing a harmonic. As you have seen, the spring force always pushes or pulls the mass towards its original equilibrium position, called a restoring force. This force is directly proportional to the mass's displacement. This is known as Hooke's law.
Section 2. Measuring simple harmonic motion.
Amplitude.
Amplitude is the maximum displacement from the equilibrium.
Period.
Period is the time that it takes a complete cycle to occur. It depends on the pendulum length and freefall acceleration.
21, 22, 23, 24, 25, 26, 27, 28, 29, 30.
Frequency.
31.
Frequency is the number of cycles or vibrations per unit of time. Period equals 2 pi times the square root of length divided by freefall acceleration.
Cinderella, just in Yalla, went to jump rope in the house. I don't know.
How can a simple jump rope, as we see right here, be used in a demonstration for physics?
Section 3, Properties of Waves. How can a simple jump rope, as we see right here, be used in demonstration for physics? Well, one of the simplest ways to demonstrate wave motion is to hold both ends, and one person flips the wrist and creates a pulse that travels to the fixed end with a definite speed. A wave that consists of a single traveling pulse is called a pulse wave. A transverse wave is a wave that vibrates perpendicular to the direction that the wave is traveling. Wave measures include the crest, trough, amplitude, and wavelength. The crest is the highest point above the equilibrium position. The trough is the lowest point below the equilibrium position. Wavelength is the distance between two adjacent points of waves.
You're like throwing it.
I know, it's hard.
It is hard. Oh my goodness.
Throw it right.
There. Oh, it works. Hey.
Oh, look at that, look at that! Oh! A longitudinal wave is a wave that vibrates parallel to the direction that the wave is traveling. This is the equation for speed of a wave. A piano string tuned to middle C vibrates with a frequency of 262 Hz. Assuming the speed of sound in air is 343 meters per second, find the wavelength of the sound waves produced by the string. Robyn uses velocity divided by frequency to calculate the wavelength, which is 343 meters per second divided by 262 Hz, which equals 1.31 meters.
Section 4, Wave Interactions. Here we have a boat placed in the water with no interference. Here is constructive interference. When added together, the resultant wave is larger than the individual displacement. This is destructive interference. Destructive interference is when the positive and negative displacements are added and the resultant wave is the difference between the pulses. When a pulse travels down a rope whose end is free to slide up the pulse is reflected from the free end. When a pulse travels down a rope that is fixed at one end, the reflected pulse is inverted. This is a standing wave, a resultant wave pattern that appears to be stationary on the string, and here we see nodes, the points at which complete destructive interference happens, and these are antinodes. Midway between two adjacent nodes, the string vibrates with the largest amplitude.
Hold on, I forgot to. Yeah.
Ready?
Honorable Father.
Oh yeah, that's right. Okay. Ready? Thank you, Honorable Father.
Number 4 data. You're not number 4 data. You're number 3 data.
Yeah.
I mean, let's back that up.
Okay.